Hi guys, welcome to chemistry lesson 8.06 on combustion. So this is our last reaction category. So far we've done 4 of the 5 categories, and today we're going to do combustion. So I'm going to actually kind of write up here at the top of my page too. So by definition, combustion is defined as combining a substance and that substance is usually, but not always, a hydrocarbon. Usually, but not always, a hydrocarbon. In a rapid manner. So one of the hallmarks of combustion is it has to happen quickly. If it happens slowly, like rusting, that's combining with oxygen too. I forgot the with oxygen. Combining a substance, usually but not always a hydrocarbon, in a rapid manner with oxygen. Should say in with oxygen in a rapid manner, but I forgot that. So if we combine with oxygen slowly, we call that oxidation. When it happens quickly, we call that combustion. So some bullet points about hydrocarbons. What is a hydrocarbon? Well, first of all, so if we're looking at hydrocarbons, one, they're made up of hydrogen and carbon. So hydrocarbons are made up of hydrogen and carbon. Number two, there are things like coal, oil, natural gas, propane, anything. So everything that we burn in our gas tanks, gas, to heat our home, those are usually hydrocarbons. Number three, they often have a little bit of oxygen. Not always. They often have some O2. And number four, they're covalent compounds. So we're talking about a covalent compound, and that's new because up until now, everything we've done has been ionic or elemental. So we're talking about a covalent compound. So for our demonstration today, we reacted isopropyl alcohol. And when we combusted it, we combined the isopropyl alcohol with oxygen. So my formula, so if you haven't seen this in class, if you're watching this at home, pause the video and go watch the link that I provided that has the combustion of isopropyl alcohol. So go ahead and do that now if you haven't already. All right, if you're coming back, welcome back. All right, so our formula for isopropyl alcohol is C3H8O. It's a liquid. And when we combine that with oxygen, that's a gas. Notice it's diatomic, so I write oxygen with a subscript 2. So the question is, what am I going to produce? Well, here in class, we looked at the fact that when we inspected the bottle, we could tell there was smoke in it, what looked like smoke. So we know we made a gas. The other thing was we dumped out the liquid, and we saw that we actually ended up with more liquid than what we started with. So we know we also made a liquid. And as it turns out, the gas was carbon dioxide, and the liquid was water. So the products of the combustion of a hydrocarbon are always carbon dioxide and water. The products of hydrocarbon combustion, are always carbon dioxide and water. Almost always. We have an exception down here because, and you'll notice we're combusting hydrogen, but there's no carbon, so we can't make carbon dioxide. So finding the product for these reactions is really pretty simple because it's always going to be CO2 and H2O. The challenge on these can be balancing. I'm going to balance this initially in pencil because I'm going to walk you through what usually happens when students try to balance. So I need to find one of my pencils. They've all disappeared. Pardon me for just a second. All right, so we said when we're balancing, you always want to balance. If something shows up more than once on the side of the equation, you want to balance that last. And I've got oxygen here and here. And I've got oxygen here and here. And so that's going to be last. If you look at carbon, I've got 3 carbon over here. I've got 3, so I'm going to put a 3 over here. And I've got 8 hydrogen, so I'm going to put a 4. That's going to give me 8. So now I need to total up my oxygens. So I've got 2 and I've got 3 on this side. 3 oxygen over here. And over here, I've got 4 and I've got 6, so I've got 10. Now we've got a problem because I've got an odd number over here and I've got an even number over here. So what's going to happen is I have to add a 2 in front of this to get this to be even, because this whole odd even thing isn't going to work out. Let's go ahead and erase this. So right away, that's going to change everything for me. So now I have 6 carbon. So I need a 6 in front of my CO2. I have got 16 hydrogen. So I'm going to need to put an 8 out here. All right, let's do another oxygen count. So now I have 4 on this side. And I have 6 times 2 is 12, plus 8, I have 20 oxygen on this side. So I've got 2 oxygen here, which means I need to have 18 oxygen here. How can I get that? If I put a 9 in front of my oxygen, that's going to balance me out. But you will almost always want to balance oxygen last. Again, so tougher problems to balance. Let's do a few more sample problems. All right, so this one's a little bit easier, actually. I have got what's called methane, CH4 plus O2. Okay, so I look at this and I go, I'm combining something with oxygen. Do I have a hydrocarbon? Yes, I do. This has hydrogen and this has carbon. So I'm going to have CO2 plus H2O. Okay, now I need to balance. This one's a little bit easier to balance. I've got 1 carbon, I've got 1 carbon. I've got 4 hydrogen. So I'm going to put a 2 in front of this to give myself 4 hydrogen. Now for my oxygen, I have 2 here and 2 here. So I have a total of 4 oxygen. So I need a 2 there. Then finally, for my last reaction, I have a hydrogen plus oxygen. And what I'm going to do for that, I have hydrogen plus oxygen. So I can't make carbon dioxide and water here because, grab my purple pen, I don't have any carbon. So what am I going to make? Well, the only thing I can make is water. Is this still combustion? Yep, this would happen explosively. In fact, sometimes I'll in the past years, I've done a hydrogen balloon. See if you can talk me into it this year. I don't know. So my hydrogen are already balanced. So now I actually have to balance my oxygen first. So I'm going to put a 2 out front here. And now I have 2 oxygen, but now I have 4 hydrogen. So I need a 2 over here to balance that. And this whole combustion of hydrocarbons is a really kind of a hot button right now because carbon dioxide, as you might have heard in the news, is a greenhouse gas. It's a greenhouse gas. And scientists believe this is one of the leading causes for global warming. And boy, that sure is a current event if you've ever checked the news out recently. So every time we burn our gas, every time we burn oil, every time we burn propane, we're producing carbon dioxide, and it's making the earth warmer. Now, whether or not you believe it's because of greenhouse gases, it is a fact the earth is getting warmer. We have mounds of scientific data Maybe it's a combination of a lot of things, but it's definitely something we have to take into consideration. And so that's why we have the push to go to things like electric cars and wind power, so on and so forth. So that is combustion. Our takeaways here is we're combining a substance, usually a hydrocarbon, quickly with oxygen, and we're always going to form carbon dioxide and water. The tricky part can come in the balancing, but the products are really easy to predict. But you have to remember, we're not working with an ionic compound anymore. There's no charges here. So this will give you get you ready to do some practice problems for homework. Okay, thanks for watching.